Hello, we're going to be looking at factors affecting file size today and why we'll need to use compression because of this, as well as the different types of compression. After that, we're going to be looking at the different image types and what type of compression they use, and the same with audio. And then there's going to be a short quiz afterwards. So part one, I've broken this into two parts just to keep the images and audio separate. So we'll talk about what compression is in general, and then we'll talk about images and audio and the types of compression they use and a few other things. So factors affecting file size and the need for compression. Before we even get to that, we're going to just talk about images. So this is revision from a couple of lessons ago. I probably should have followed this up straight after. This is actually a completely different topic, as in it's a different section. So that the image section came under the computer systems topic. This comes under the web design topic. Now, even if it's a different topic, it does kind of build off on this. So we're going to quickly revise that. So bitmap graphics are made up of an array of pixels. So if you were asked this in an exam, if you said they're made up of rows and columns of pixels, you would get the 1 mark, but you need to say array for the second mark. Color depth is how many colors a image has access to. So a 24-bit image is the true color ones, which is 16.7 million colors. That's enough to trick your human eye into thinking that it looks real. So this picture of the cat, it's 8 bits on this side and 24 bits on the other side. As you can see, it doesn't even have the colors to represent this side of the ear, so it's made it this weird kind of green color because it's only got 256 to work with. So on to the new stuff. As we've just said, color depth is, well, that's what we just talked about, but this is kind of obvious. The larger the color range means you've got a better quality picture, and if you've got a better quality picture, you've got a larger file size. This is under the context of factors affecting file size, so obviously having more colors is going to mean a larger file size. Resolution, if you have a better resolution image, so like a HD image, so a 1080p image will be better than a 720p image, and a 4K image will be better than a 1080, and so on. The more pixels you have on screen, the better quality picture you have, and believe it or not, it's going to give you a larger file size. And the higher the resolution and range of colors, the better the image quality and the greater the file size. This just sums up this all in one sentence, really. So if the picture looks better, it's going to take up more space. So we need to look at compression from there onwards. Before we get to that, we're going to talk about audio. This isn't something we've looked at before. Same kind of idea. We've got something called the sampling rate. So the sampling rate is, we've got your voice. I'm talking right now. This is an analog signal, right? So the computer will read it through the microphone and it will come across like this. Now, the higher the sampling rate that your computer is set to pick up, the better the quality of the sound. And so sampling rate actually turns this analog signal into a digital signal. So digital signals are zeros and ones. It's kind of the blocky steps. And like the voice obviously fluctuates when you speak. So it's turning it into a digitized signal. And the sample, obviously a little bit of quality is going to be lost. If you're speaking to someone over the phone or you're listening to a recording, it's not the same as having somebody in the room with you. It's going to sound slightly different. It might be high quality, but it's never going to sound the same as real life. That's because a little bit of quality is lost when it's digitized, when it goes from this analog signal to a digital signal. The idea is, if you have a higher sampling rate, you're not going to notice this as much, and you're going to have a better quality sound. So the higher the sampling rate means better quality sound, and obviously it means a larger file size. You probably see where this is going next. So the larger file size means compression needs to be considered. So let's actually go on to compression. So compression is just reducing the size of a file. The most common one is a zip file. So if you go into your documents, you just right click and you say add to a zip folder. That's the most simple form of compression. It's going to make your files take less time to upload and download. It's why a lot of people upload their documents into zip files, or to send across emails as well. Emails actually have a max limit that you can do, so a lot of the time you have to zip them up first. Kind of obvious. More files can be stored on a computer system. I wouldn't recommend putting everything in zipped files, but we're going to be talking about compression, and if the things we're going to be talking about weren't compressed, file space would get out of control or you'd run out of it quite quickly. This can be applied to images, audio, or video. Notice video is not in bold. It's not that it's not important, it's just that we're not going to be talking about it today. So we're just going to focus on image compression and audio compression. So there's two types of compression. There is lossy. Now, lossy compression actually removes data from a file to reduce the size drastically. So it will be a tiny file after you compress it the lossy way. However, you'll lose quality in your file. So whether it's an image, the image will look more blurry, or if it's a recording, it won't sound as good. And you cannot get this back. So this is why if you use lossy compression and you have an image and it looks a bit pixelated, and then if somebody, say, took a screenshot of that, that screenshot is probably lossy compressed and it'll look more pixelated, and then if somebody takes a screenshot of that, it'll look more pixelated again, and every time somebody takes a screenshot, it's just going to get more and more pixelated and you're going to lose more and more quality. So think of it like a photocopier. So if you put a bit of paper in, you've got your original, you photocopy it, comes out maybe not 100% the first time, but if you keep photocopying those same photocopies every time, you're going to lose more and more quality. Lossless compression, however, shrinks the whole file. Now, file size is still reduced, but just not as much. So that's why this one is better in some circumstances. However, the quality of the file remains exactly the same. You're not going to notice any difference. I feel a bit weird adding this in. We're actually going to watch a video, like a reaction channel. It's only 30 seconds long or so. I just think it sums up this really well. I will have to turn off my sound, otherwise you'll hear it twice. So let's just follow this. So this is from BBC Bite Size, and I'll just let it play.
Compression. We use compression to reduce file sizes. It makes it easier to store, stream and download videos, audio and other digital assets. There are two types of compression, lossy and lossless. Lossy compression means removing data to reduce the file size, but lossless compression shrinks the whole file, keeping all of the quality. With lossless compression, files can be restored to their original state. With lossy compression, once you've removed the data, it's gone for good.
Right, so what happens there is, so the lossy compressed one, it showed you like a video, because this can be applied to videos as well. So the lossy compressed one, the quality doesn't look great, although the file size is much smaller at the end, whereas the lossless one is shrunk instead of having quality removed, and you can just get it all back very easily, and the quality isn't reduced. So that's the key differences. So let's go into part 2, which is standard file formats, and we're going to be again talking about which image types, which audio types use which types of compression, and a couple other things that you need to be aware of. This is all the context. I know we're jumping across topics. I'm just trying to cover all the theory. This is in the context of web design. So like what images would be best in what circumstances for web design. So the main file formats we're going to be looking at are JPEGs, GIFs and PNGs. JPEGs, sometimes written as .jpeg, if you're writing it for a website, like a bit of code, HTML, you have to do .jpeg. If you do the E, it will freak out. Now this is what it's actually called. I can't remember what it stands for off the top of my head, doesn't really matter. The reason is because the computer can only handle, or it used to be able to only handle 3 letters at the end of a file type. So they had to cut out the E. That's it. So this is how you won't be marked down if you wrote this in an exam, but this is how we write it when we're using HTML. This is how you just spell it out any other time. So JPEGs are the most common image type. Most cameras will default to this, so if you're using it on a phone or whatever, and they are 24 bits, which we have discussed before, is true color, and they have 16.7 million colors to work with, which is enough to trick the human eye into thinking they look real. However, they are lossy, so if you keep getting, like I said before with the photocopying example, if you keep taking screenshots of the same image, if you keep going into editing software and then pasting it into another editing software, you're going to eventually lose quality. They do display photos well on a screen though, but if you were to print them out, they won't look quite as good. Complete side note, apparently this is like a award-winning photo from 2047. Apparently it's not photoshopped, which I don't quite believe, but apparently it's not photoshopped. GIFs, we will be pronouncing it GIFs. If you pronounce it GIF, sort your life out. They are a series of low quality images. Now they're low quality because they're animated. If you had the same quality as a JPEG, the files would get very large. So they're only 8 bits each, which means you only have 256 colors. So they're really good for like cartoons and that type of thing. If you do see, it's right, if you see a GIF of like a person or whatever, or let's be honest, if it's like a dog or a cat GIF, it's going to look more pixelated because it's only got 256 colors to work with. And it's just to keep file size down, like I said. They can be transparent, so keep that in mind. So they can have, where did the other guy go? There was meant to be another guy here. So they can be transparent, so that's this bit here, but they don't have to be. And they use lossless compression. Now lossless, you might think, well, lossless is that's the good quality one. Why is this low quality image? It's just because I don't think you actually can afford to lose any more quality, otherwise it become even more pixelated, so it's lossless. Right. PNGs stands for Portable Network Graphic. They are 32 bits and they have a range of 16.7 million colors, so they're true color. Now, if you're thinking, why has it got the same amount of colors as a JPEG, but it's got 8 more bits? The first 24 bits are used for colors, your red, green and blues, and it mixes them in different ways to get 16.7 million. The extra 8 bits is something called the alpha channel, and it allows it to be transparent or even different degrees of semi-transparent. So whereas this one is just a yes or no, oh look, the guys came back somehow. It's either transparent or it's not. This one you can actually get layers of semi-transparency, so if you have other images behind it, you can kind of have them fading in, and that's what the alpha channel deals with. I believe because it's 8 bits, it has 256 levels of transparency, like different degrees of it. So if you made it say 128, it would be 50% transparent. The reason I've put this image here is you might recognize these checkerboard patterns if you go on Google Images or whatever. That means it's a PNG without a background. Sometimes you'll get this because you accidentally saved the PNG as a JPEG, but if you download it as a PNG, you won't have the background and it'll look like this. And this is the PNG saved as a JPEG, so it's got a background. They use lossless compression as well, so they don't lose any quality. Now, when we're talking about GIFs, obviously some of them look pixelated, but you might be thinking, especially recently, sometimes you watch a GIF and it's not very pixelated, it just looks like a normal video. That's because it's a kind of a newer thing, as like broadband connections are getting better than that, and people have started using something called APNG, so Animated Portable Network Graphics. This makes it possible to make an animated PNG, which means the file size is going to be huge, because it's going to have, rather than a bunch of animated 8-bit images, which like a GIF's like a flip book of 8-bit images, you're now going to have an animated 32-bit image. It's basically just a video at that point, but maybe minus sound. So yeah, let's compare them quickly. So this should be lossless, my apologies, I'll change that after. So the only lossy one is JPEG. Again, JPEG is the only one that can't be transparent. It's the only one that can't be animated. It just seems a bit left out, to be honest. I put depends here for animation. That's only because not all of them can have it, and you have to go out of your way to do it. If you were ever asked in an exam, what image would you recommend for web animations, I would go to this one, especially because the first one, that seems like the safer answer, but you can make a point that this one can be animated as well. This is best for photos on websites. This is best for web animations, and I think my face is covering this box. I don't know if I mentioned this actually, no I didn't. The PNG, although the JPEG will look pixelated when printed out, like on a big piece of paper, like if you were going to cover an entire wall, PNGs will look great on it. So that is kind of the go-to for large scale printing. So when you see ads in that, billboards, they're more than likely made with PNGs. Right, last little topic, I don't want this video to be too long, is the two types of audio. So we've got MP3s and WAVs. This is the most common type of audio and the one most people are familiar with. It uses lossy compression, so that means it's getting quality extracted from it. However, it uses something called perceptual coding, which is where it tries to take out background noise that maybe you don't want, and it tries to look for sounds that you can't even hear. So you're not even going to notice the difference. I say most people, maybe some music snobs would say they notice the difference, but most people won't notice it if you're just listening to Spotify or whatever. So yeah, most people won't hear it unless you're like a dolphin or a bat or a dog or whatever, and that's perceptual coding. The smaller file size obviously gives it an advantage for streaming or downloading from websites. The other one, however, WAV, it uses lossless compression, so no quality is lost. It does have a huge file size though. It's awful for streaming as a result. There'd be a delay every time you had to start up a new song. It is good for music editing. Now, why that is because you've got, I've talked about these sounds you won't even notice before, right? But say you're an aspiring DJ, you're gonna mix that song by like making different parts of somebody's voice higher or lower, or maybe even sounds in the background. You're going to be playing about with sounds and like amplifying them or decreasing them, that and then getting that. If you tried being a DJ with an MP3, you've lost all that natural sound that you can play about with, and you wouldn't be able to do much of it. So music editors tend to use this. And yeah, lossy, lossless, small, large. This is good for streaming. This is good for music editing. There's not much more to say about that. Right, I've talked for long enough. This is the little quiz for this week. Right, thank you for listening.